All right, the purpose of this video today is to understand and explore the concept of number composition and decomposition. Number composition is simply understanding that all numbers are composed of other numbers. Having this understanding is a foundational building block in establishing a strong sense of number. So let's take a look at what this exactly means. So I am looking at the number 8 here. I have the number 8, and I can see that, well, number 8 is composed of a 1 and 7. 8's also composed of 2 and 6, and 8 is composed of 3 and 5, and so on. I can look at 65. 65 is composed of a 60 and a 5. 65 can also be thought as 50 and 15, or a 30 and a 5. I'm going to decompose 3/4. I've decomposed 3/4, and I can see that 3/4 is composed of 3 of the 1/4, or 1/4 plus 1/4 plus 1/4. I can decompose 57/100, thinking that 57/100 is composed of 5/10 and 7/100. So why is it helpful to understand this concept? This concept allows for flexible thinking, reasoning, and visualization. All components that help build a strong sense of number. So now I am going to put some numbers together. I have 6 plus 8. This is not a fact I need to memorize. What I need to have automatic is the understanding that numbers are composed of other numbers. So 6 plus 8, I don't know. But I know that 8 is composed of 2 4s, and I know that 6 plus 4 is 10. So in 4 more is 14. Therefore 6 plus 8 is 14. We'll look at 16 plus 8. My low-tech presentation here. 16 plus 8. Again, not a fact I need to memorize. It's the automaticity of being able to say, I've got a strategy. 16 plus 8. Well, 8's composed of 2 4s, and that's helpful because I can say 16 plus 4 is 20, and 4 more is 24. Therefore, 20 plus 4 is 24. Again, so now I have I have 26 plus 18, and we're going to decompose this in a different way, practicing our flexible thinking. So now I've chose to decompose 26 into a 24 and a 2. That's helpful because I know 18 plus 2 is 20, and I still have another 24 from that 26. 20 plus 24 is 44. Or kids will look at it right away and say, oh, well, I know that. 20 plus 20 is 40. 4 more is 44. Let's look at it a little differently. I have 44 minus 17. One way to think of it is I'll just decompose my 17 into friendlier numbers. 44 minus 14 minus 3. 44 minus 14 is 30. Minus 3 more is 27. There is a different way. 44, now I've decomposed my 17 into a 10 and a 3 and a 4. So 44 minus 10 is 34. Minus 4 more is 30. Minus 3 more is 27. Again, I am decomposing numbers to see what's inside so I can use friendly numbers. Now let's take a look at 113 minus 87. Well, I could decompose 87 into some parts. But here I'm going to practice my flexible thinking, and I'm going to say, you know what? That's not the best strategy for this. I'm thinking, well, what are we doing here? We're looking to see what's different between those two numbers. 113 and 87, I'm comparing them. They're reasonably close. I don't think I'm going to practice decomposing a number. Instead, I'm going to flip this around and think of it as 87 plus what equals 113? Well, I know 87. I can use what I know about 10. 87 plus 13 is 100. Oh, well, now I just have to add another 13, and I'm at 113. So, therefore, I've added 2 13s, or 26. A strong sense of number leads to flexible thinking, reasoning, and visualization. All of these are what can really help solidify a student's ability to compute mentally. So now let's look and see what that looks like in the multiplicative world. 7 times 4. Not a fact I'm going to memorize. What I want to have automatically or memorized is my strategy. If I don't know 7 times 4, I want to have a way to figure it out. Inside my 4 is a 2 and a 2. So I do know 7 times 2 is 14. Well, there's 2 of those. There's 2 14s. So 7 times 4 is the same as 7 times 2 plus 7 times 2. Or 7 times 4 is also the same as 14 plus 14. Let's look at that again. So now I have 7 times 6. This is a fact that kids are frequently missing. And again, not focusing on memorization. Memorization is not going to get me so far. True understanding of number sense and how to compose and decompose numbers, that's going to get me much further. So now 7 times 6, don't know it, but 6 is composed of a 5 and a 1. I do know 7 times 5, and I do know 7 plus 7 times 1. 7 times 5 is 35, plus 7 times 1, which is 7. So therefore 7 times 6 is the same as 7 times 5 plus 7, or 35 plus 7. Being able, so I'm going to use this example one more time, being able to decompose a number is going to help me when I'm dealing with numbers once they become much more complex. If I'm simply memorizing my facts, I'm not going to be able to, that's memorization is not going to lead me to the next level. So here's the next level. Now I have 14 times 7. Uh-oh. If I memorized 4 times 7, that's not going to help me right here. I'm going to be in trouble. So what I'm going to do is I can use what I understand about how numbers are composed and decomposed to make this into a much simpler problem. I'm going to decompose my 14 into a 10 and a 4. I know 7 times 10, and I know 7 times 4. So 14 times 7 is the same as 7 times 10 plus 7 times 4. Establishing a strong sense of number is a truly important skill for all elementary learners, which leads to efficient strategy, use of strategies. If students do not have that strong sense of number, efficient strategies such as standardized algorithms aren't going to make sense. Kids will start to follow directions and they can all follow rules. However, if they don't have that strong sense of number, they're not going to have that capability of then reasoning about their answer to determine whether or not they are accurate. This presentation is all about understanding the composition and decomposition of number and how that is a foundational skill to help build that strong sense of number.